morning, guys. Hope you're doing well and had a fabulous weekend. So today we'll talk a little bit more about absolute value functions. Now, I hope you remember from the toolkit functions that the absolute value function is the function, this one, and that its graph looks like that. This is the origin, its graph looks like that. So the question we have here right now is, does this graph always intersect the x-axis? The y-axis, that's the x-axis. Does it always intersect the x-axis? What do you guys think? So we know it can be drawn like this. It can be drawn like different reflections or transformations can happen to this function such that it's drawn in all sorts of ways. It could be drawn like that. But does it always have to cross the x-axis? That is the question today. Are there some cases where it doesn't cross the x-axis? The answer to that is yes. There's going to be situations, just like you see in some of these graphs that I've drawn, there's going to be situations where that function does not cross the x-axis. So like that, like this here. It doesn't always have to cross the x-axis. And when that happens, because you know that for generally when a function cuts the x-axis, those points where it cuts the x-axis are called the roots or the solutions or the zeros of that function. So when this function is drawn and it's not crossing the x-axis, then that's one way we can know that that function does not have any solutions or any zeros or any roots. So if an absolute value function does not cut the x-axis, it doesn't have solutions. Not having solutions, talk about a little bit what that might mean. If I have an absolute value of maybe x minus 2, and that's equal to, say, 4. Could that equal to 4? Yes, that's a valid one. We try to think of one that would not have a solution. If that was equal to, say, negative 3. Yeah. So if that's equal to negative 3, this function is not going to cut the x-axis because it doesn't have any solutions. I hope you can see that if I try to solve for this, which is what we're getting into, if I try to solve for this, x minus 2 could equal, if I try to graph this, let me try to graph this. Or even solve it. X minus 2 can be equal to 3, or x minus 2 can equal negative 3. So if x minus 2 is equal to 3, then I have x equal 5. And if x minus 2 is equal to negative 3, then I have x equal negative 1. Now ask yourself, if I put 5 in here, I substitute for x as 5, and take the absolute value of that function, does it give me 3? Negative 3. The answer is no. If I put negative 1 in here and I solve for it, does it give me an absolute value of negative 3? The answer is no, because an absolute value simply means positive value. It can't be a negative. So this is one example of a function, of an absolute value function that will not cut the x-axis. If I try to graph this, I'm going to first take the 3 to the other side. Then my fx would equal x minus 2 plus 3. This means it moved 2 units to the right and moved 3 units upward. So it's going to be 2 units to the right and 3 units up. So it's going to look like that. As you can see, it doesn't cut the x-axis. Okay, yeah. So what does this tell you about the possible solutions to an absolute value equation? This tells me that sometimes I will have solutions to an absolute value equation, but sometimes I will not have solutions, especially when it does not cut the x-axis. So you don't always expect to have solutions. Here's an example. If I want to solve for this absolute value equation, 2x minus 6 is equal 8, I know that an absolute value of something, the input can be a positive number or a negative number. That's what I know, that the input can either be a positive number or a negative number, but the output is going to be a positive number. So here I know that the input this input could equal two things, could equal a negative 8 or could equal a positive 8. If it's equal negative 8, then I'll have 2x equals negative 8 plus 6, which is negative 2, which tells me that x equals negative 1. And if it is equal to positive 8, then 2x minus 6 equals 8. Sorry, these absolute symbols shouldn't have been there. Let's see, or 2x minus 6 equals 8, in which case I have 2x equals 8 plus 6 is 14, and therefore x is equal to 7. So those are my two solutions to this absolute value equation. I can try to test them. If I put negative 1 here, that will be negative 2 minus 6 is negative 8. The absolute value of that is positive 8. If I put 7 here, if I put this 7 in here, then I'll have 14 minus 6, which still is 8. So this one has solutions, and even when I test them, the equation is valid. For this function, find the values of x such that the function is equal to 0. So I'm just going to get this whole equation and equate it to 0. And then I try to solve for x. So if it's an equation, meaning equal sign, I try to isolate the absolute value section of the equation. So I'm going to try and isolate this one so that it's alone on one side of the equation. That's going to be 3x plus 1 equals 6, because the 6 will go over to the other side. It's equals 6. Now I know that the input to this absolute value equation could be a positive or a negative number, but its output will be a positive. So I know that the input could have been 3x plus 1 equal negative 6, or 3x plus 1 equals 6. I'm going to solve those two equations. If I divide by 3, you guys can use any algebra that you want to solve this. If I divide by 3, then I'll have x plus 1 equals negative 2. And then when the 1 moves over to that side, like I said, you can use the algebra that you like to solve for this. And solving for this one again, I'm going to divide by 3, and then 2 minus 1 is 1. Okay, so those are my two solutions to this absolute value function. Yeah, so I have 1 and negative 3. Wait, did I get it right? Yeah, I did. So what would the graph of this function look like now? If you look at it, what would the graph look like? From this, you can see that it is moved 1 unit to the left along the x-axis. This can be thought of as a vertical stretch or as a horizontal compression of 3 units. So instead of having a slope of 1, you would have a slope of 3. I hope you remember that the slope would have been 1, which is the compression or stretch. It's supposed to be 1, but instead of being 1, it's going to be 3 for this equation. And then after that, it's moved down 6 units. Okay, so let's try to graph it. It's supposed to be here initially, but it's moved 1 unit to the left. So here, the slope of 3 instead of 1. So another way that you could solve for, but yeah, we already have the factor, so we don't need to solve for it. We already have you can think of it as a vertical stretch or a horizontal compression. So moved here, and now it's supposed to be, would have gone like this to that point and to that point, but the slope is now 3 instead of 1, so it will instead go to that point and to that point. I hope that makes sense. This one was a slope of 1, this one is a slope of 3, because the rise is 3 and the run is 1. And then after that, it moved down 6 units. So 1, 2, 3, 4, 5, 6. So it starts here and has a slope of 3. Goes here, goes here, goes up there. So let me just draw that line again. 1, 2, 3, 4, 5, 6. So it's going to go here. It starts here, goes here, goes here, goes here, and there, up there, up there, that point and that point. So just oop, oop. That's my graph, and let me take out this side. Yeah, so that's what the graph of that function would look like. Another example. Again, if you're solving examples like this, the first thing you want to do is to isolate this section of the equation, the absolute value section of the equation. So if I'm doing that to this expression, I'll have 4x minus 2. When the 2, because I want to isolate it, this 2 is going to move over to this way. It's going to become a negative 2. Then I'll have is equal to negative 1. Still try and isolate it. I'm going to divide this by 4, divide that by 4, and I end up with x minus 2 is equal to negative 1 over 4. Now, I can go ahead from here and say x minus 2 equals negative 1 over 4, or x minus 2 equals 1 over 4. I can go through all of this pain and process only to get to the end of it and realize that it has no solution, and I can see that from this point where I have a negative sign on my output for this function. Because you know that an absolute value function or equation cannot have a negative output. All of its outputs are going to be positive. There's nothing you can put inside these absolute value symbols to give you a negative answer. And therefore, I know that this function or this equation has no solution. So just by seeing this, I can just go ahead and tell that it has no solution. Or if I doubt that, I can go through this whole process, but I'll still come to the same conclusion. So yeah, this one does not have any solutions because it's equal to a negative. And what does the graph look like? Well, let's see. If I rearrange it, this time I'm going to put the one over here. That it looks like everything is on one side. That's going to be 4x minus 2 x minus 2 plus 1 when the 1 moves over. So my f of x is equal to that. Now I'm going to graph that. Remember, the 2 means it moved 2 units to the right. The 4 means the slope is 4 instead of 1. And the 1 means it moved 1 unit up. So, sorry, 2 units to the right, it's right here. A slope of 4, okay, 1 unit upwards, it's going to end up starting here. And remember, it has a slope of 4, so instead of going here, it's going to go 2, 3, 4. It's going to go there. It's also going to go there. Let me draw it better. Yeah, slope of 4, 1, 2, 3, 4. It's going to go there. And it's going to go here. It's going to continue like that. 1, 2, 3, 4. 1, 2, 3, 4. So that's what my graph is going to look like. And I hope you can see that the graph does not touch the x-axis. Not touching the x-axis means it has no solution. That's what we talked about earlier. And this we've been proved correct or true. All right. Alright, we have another example. Now this is an absolute value inequality, not just an absolute value equation. There's two ways we can think of this. One of the ways is to think of it as an absolute value equation. Now, if I think of it as an equation, I can have x minus 5 equals 4 or x minus 5 equals negative 4. If I solve those two, I'll have x is 9 and x is 1. Now, this just tells me the values of the solutions. This just tells me the solutions of this function, right? It doesn't tell me all. Let me repeat that. It just tells me the zeros of this function. It just tells me the values of this function where it cuts the x-axis. If I were to graph x minus 5 minus 4, if I were to graph this f of x, this is where these two values, x equals 9 and x equals 1, those are the values of x where that function would cut the x-axis if I were to graph it. But those two values by themselves do not tell me where the solution set of this inequality lies, because you know an inequality is supposed to have a solution set. So if I want to know what the solution set of this inequality would be, first of all, like I said, there are two ways. This is the first one where you've done this step, and then after this step, you go to you look at this value 1, and you look at the value 9, and then ask yourself, what does the function look like before, or do values before 1, what's happening to this time? Do values before 1 satisfy this inequality? Do values between 1 and 9 satisfy the inequality? Or do values after 9 satisfy this inequality? I hope that makes sense. Because, to repeat, what you have got, the 1 and 9 so far, those are simply zeros of the function. If I were to graph that function, just ignore what you see here right now. If I were to graph that function, it would have been 1, 2, 3, 4, 5 years here, and then going 4 units down. 1, 2, 3, 4. So it would have started here, and it would have cut the x-axis at this point, and at 9 somewhere this way. That's what it would have looked like. I'll explain what the green and the purple are in a bit. So if it looks like this, what that means, what I'm trying to say now is, ask yourself, what does this function, or do the values of x before 1 satisfy the inequality x minus 5 less than 4, right? And then ask yourself again, do the values of x between 1 and 9 satisfy the inequality, or is it the values of x after 9? Because remember, you're looking for a solution set. Now, if I use the value of x that's less than 1, if I put 0 in this absolute value inequality, if I put 0 minus 5, then I ask myself, is that less than 4? The answer is no, because 0 minus 5 is 5 absolute positive value, is not less than 4. So I know that this section is not wanted. Like this section before 1, that does not satisfy my inequality. Let me check for the section between 1 and 9. I can pick any number from there. Let me pick the 4. 4 minus 5 is the absolute value of that, less than 4. The answer to that is yes. So I know that any value between 1 and 9 is going to satisfy the inequality. And then I finally can check for value that's bigger than 9. 10 minus 5. Even if I try 9 itself, 9 minus 5 is that less than 4? From 9 onward. 9 minus 5 is 4. That's the value of 4 is 4. Is 4 less than 4? The answer to that is no. So that tells you that 1 and 9 are not included in the solution, but that already was told to you by this part of the equation. So your solution set can be written as 1 x 9. Simply as that. You can write your solution set as 1 x 9, and this would be the solution to this inequality equation. I told you that is another way you could think about it. Another way you can think about it is x minus 5 less than 4, I know that being an absolute value inequality or function, I could have a negative or a positive output. Sorry, I could have a negative or positive input, and that will give me the same output. So then I'm just going to solve for this equation. I'll add 5 here, I'll add 5 there, and then I'll also add 5 here. On the left hand side, negative 4 plus 5, I have 1, x, and 9. And that gives you the same solution as what you got earlier. Alright, so question, what does the graph of f of x minus 5 less than 4 look like? So what you see drawn here in this graph is two functions. One function is y is equal to 4, and another function is y is equal to x minus 5. So if you split those two functions and you graph them differently, then you're going to see that where they still meet, where they intersect, is still at x equals 1 and still at x equals 9. That's still going to be the points where they intersect, and remember those are the solutions to your function. And the values of this function that you're interested in are going to be values in that section, between 1 and 9 only. So if I've drawn these two graphs, then that's what that looks like. If they ask me to solve x minus 5 is equal to 4, from this graph I can just see that the answers are 1 and 9. If they want me to solve for x minus 5 is greater than 4, absolute value of x minus 5 is greater than 4, this I know that these are the points where they meet, and I know that this region here, this region in the middle, satisfies the equation x plus 5 less than 4. So if I'm looking for the solutions which satisfy the equation x plus 5, sorry, x minus 5 less than minus, it's not a plus, in the middle here is a minus. If I'm looking for the values that satisfy the inequality equation x minus 5 greater than 4, those are going to be values that are outside this region, which is going to be this side and that side. So my solutions to that would be x is less than 1 and x is greater than 9. Okay, so your turn. Try these questions. If you have any questions, please send an email. I respond faster to emails unless your question is not time sensitive.